Hello class, today we're going to talk about solving equations. Now, I'm going to go through a couple sections in chapter 6 here. So the section will be up in the top left corner along with the example number. But before we get to those, a couple things to remind you of. First, the golden rule of solving equations. Alright, you need to remember the golden rule of solving equations. Whatever you do to one side of the equation, you must do to the other side. Alright? So we have to keep equations balanced, so whatever we do to one side, we do the exact same thing to the other side. A couple tips to help you. First, keep your work neat and organized. I cannot stress the importance of this enough, especially when I'm trying to give partial credit. When you get a question wrong, make it easy for me to give that credit by keeping your work neat and organized so I can tell what you're doing. Second, one step at a time. I see many students trying to do more than one step at a time, and that's when they start messing it up. And last, show all work again. That plays into that first thing. I want to give you partial credit, but I can't if you don't show your work. So let's get started. First, we'll start pretty simple with just one-step equations here. Our goal when solving equations is to get our variable all alone. So as we can see, my x is not alone on the left side of the equation. Notice we have the line separating the sides of the equation because we are adding a 2 to it. Now the opposite of adding 2 is subtracting 2. So if I subtract 2 from the left side, what that does is that cancels out that 2, leaving just the x behind. That'll be equal to, now here's the thing, we need to follow that golden rule of solving equations. So if I subtract 2 from the left side, I need to subtract 2 from the right side as well. 8 minus 2 is 6. That gives me my final answer. Next, you may have to deal with a subtraction. So here, our goal is going to be to get n alone. Now we can see that n is not alone on the left side of the equation because we are subtracting 4 from n. So we do the opposite. The opposite of subtracting 4 is adding 4. Now, of course, if I add 4 to the left side, I better add 4 to the right side. Let's see what that does. On the left side of the equation, negative 4 plus 4 cancels out, leaving just that n behind. And over here, negative 2 plus 4 is 2, which leaves me my final answer of 2. So both those problems were from section 3.1. We then move on to section 3.2. Now if you look here, you'll notice that my x is not alone on the left side of the equation because it's being multiplied by a negative 3. So what we need to do is we need to do the opposite of multiplying by negative 3. We are going to divide by negative 3. Now, of course, if I divide the left side of the equation by negative 3, I need to follow the golden rule of solving equations. And I need to divide the right side of the equation by negative 3. What that does is cancel out that negative 3 in front of my x, leaving just my x behind. And on the right side, negative 18 divided by negative 3 is 6. You may run into a situation where your variable is being divided by some number. So n is not alone on the left side of the equation because it's being divided by 2. So we do the opposite of dividing by 2. We are going to multiply by 2. Now, of course, if I multiply the left side of the equation by 2, I need to follow the golden rule of solving equations. And I'm going to need to multiply the right side of the equation by 2. What that does is that cancels out that denominator of 2, leaving me with just simply n. Then 11 times 2 is 22. Those last two problems were from section 3.2. Now, 3.1 and 3.2 probably should have been blended together to just be one-step equations. Because once we get past 3.2, we move on to ones like this where we're going to have to do more than just one step to isolate our variable. So, same question applies. Why is x not alone on the left side of the equation? Well, there's two reasons here. First, it's being multiplied by 3. And second, we are adding 7.
Tiffany, come to the main office. Your ride is here. Tiffany, please come to the office. Your ride is here.
So we are going to need to undo both of those operations, both the multiplication by 3 and the addition of 7. Now, typically speaking, when we have those two types of operations going on, we like to get rid of the addition or the subtraction first. So first, I'm going to get rid of the plus 7. The opposite of adding 7 is subtracting 7, and I need to do that to both sides of the equation. What that does is that cancels out that 7, leaving me with just the 3x that drops down with it. Negative 8 minus 7 is a negative 15. And now x is not alone because it's being multiplied by 3. So we do the opposite of multiplying by 3. We are going to divide both sides of the equation by 3. What that does is it cancels out the 3, leaving me with just the x on the left side. Negative 15 divided by 3 is a negative 5. So this would be a 2-step equation. Thank you. This would be a 2-step equation. Next, another example from 3-3, just multi-step equations. Now, hopefully what you notice here, we have this kind of weird situation where we have more than one term that contains x. So as we know, we can simplify that by combining like terms. So the first thing I'm going to want to do here is I want to combine the like terms of 7x and negative 3x. Now 7x minus 3x gives me 4x. So I rewrite my equation. And now this looks a lot like the question we had in the previous example. Why is x not alone on the left side of the equation? Well, it's being multiplied by 4, and we are subtracting 8. So we need to undo both those operations. Typically speaking, you're going to want to start with the addition to the subtraction. In this case, it's a subtraction. So we're going to get rid of this minus 8. Now the opposite of subtracting 8 is adding 8. And if I add 8 to the left side, I better add 8 to the right side as well. What that does is cancels out that negative 8, dropping down that 4x. 24 plus 8 is 32. Now we look at x, and it is not alone because we are multiplying it by 4. So we do the opposite of multiplying by 4. We divide by 4, leaving me with just an x on the left side, which is our goal, is equal to 32 divided by 4 is 8. Sometimes we need to simplify one side before we can start solving. Let's keep going. Another one from 3-3. What you'll see a lot is we'll have a number multiplied by a group of numbers where we're going to have to do the distributive property. Now, typically speaking, when we have that distributive property in the equation, we want to do that first. So let's go ahead and start by distributing this 3 to both terms. So that leaves me with 5x plus 3 times x is 3x plus 3 times 4 is 12 is equal to 28. Just like the last example, when I have two terms on the same side of the equation that are like terms, we can combine those. 5x plus 3x gives me 8x. When we have an equation that looks like this, where there are two operations happening to our x, we typically want to get rid of the addition first. So the opposite of adding 12 is subtracting 12. So we do that to both sides. What that does is cancels out my 12, leaving me with just 8x is equal to 28 minus 12 is 16. And my last step, x is not alone because it's being multiplied by 8. So we do the opposite of multiplying by 8. We divide both sides by 8. That cancels out the 8, leaving me with just x equals 2. Moving forward. Let's go on to that 3-4. So in section 3-4, they throw another challenge at us. What they like to do now is they'll put a variable on both sides of the equation. They'll put a variable on both sides of the equation. Now, I've seen a lot of students make the mistake of just trying to combine them, but the thing is you cannot combine like terms past this yellow line. You cannot combine like terms on different sides of the equation. So what we're going to do instead is we are going to use these steps we've learned in the last few problems to move some things around, then we'll be able to combine. Let me show you how. So when you start and you have variables on both sides of the equation, we typically like to get all of the variables to one side of the equation first. Now in this case, I don't like that I have a negative coefficient in front of my variable, so I'm going to move this negative 2x. Now, the opposite of negative 2x or minus 2x is adding 2x. So what I'm going to do is I'm going to add 2x. Now, of course, if I add 2x on the right side of the equation, I need to add 2x on the left side of the equation. And let's see what that does. 7x plus 2x is 9x. 19 just comes down. Now on the right side of the equation, negative 2x plus 2x cancels out, leaving me with just that 55. Now this looks like a problem we just had. Let's start. Again, we have two operations happening to x. We're multiplying it by 9, we're adding 19. Let's start by getting rid of that addition. I'm going to subtract 19 from both sides, leaving me with 9x, because that 19 cancels out, is equal to 36. We then divide both sides by 9. We get x is equal to 4. So, if we have variables on both sides, just move it to the other side by canceling it out on one of the sides. And last, in 3-6, you're going to see some problems that have decimals in them. Now, not to worry, we're going to do the exact same thing, except now, we're just going to have to deal with some decimals. No big deal. So looking at this, I have variables on both sides of the equation. So let's go ahead and get all of my variables on one side of the equation. Now, if I move this 0.2x over to this side, I'm going to be left with nothing on the right side of the equation. So what I think I'm going to do instead, I'm going to subtract 3.5x from both sides. And here's what that does. That's going to cancel out that x term on the left side of the equation, leaving me with just that. Now be careful here, carry that down that negative with it. So it's going to be negative 37.9. And then 0.2 minus 3.5 is negative 3.3x. And now we have x, we have our variable on the right side of the equation, but that's fine. We still want to get it alone. X is not alone on that right side of the equation because it's being multiplied by a negative 3.3. So what we're going to do is we're going to divide both sides by that negative 3.3. Leaving me with x is equal to, I don't know, negative 37.9 divided by a negative 3.3 gives me 11.48, or let's go ahead and round that to one decimal place, 11.5. So, a couple things as you're looking through these examples. First, I want you to notice how neat it all is, how I'm showing every single step. You don't necessarily need to show it in a different color like I do, all right? But the biggest thing is I draw that line down through the equation, and every single time I write an equal sign, it goes on that line. It helps keep things neat and organized. You'll notice I did that with every single problem. I had that line coming down, and every equal sign fell on that line. That will help keep things neat and organized. Okay? Like I said, do one step at a time. Doesn't necessarily need to be in a different color. And last, show all work. So I can award you. Make me want to award you points for the work you're doing. All right. Good luck. Practice.